Okay, so under our physics control menu, we could go ahead and press add active to this cube, and of course it becomes highlighted in green because it is now part of a group. And that group is, if we right click over here in our outliner and go to view groups, it is now part of this rigid body world, which any objects belonging to this group now will be a part of a physics simulation when we press the play button. As you can see there, the cube falling to oblivion. So I'll press pause, go back here, and right click and press go back in my outliner to get my regular outliner view back. So what is a collision? Well, a collision is just when two things touch each other. So for a human being, collision detection is really easy. So we can use our eyes to tell if something has touched something else, such as one car running into another car, or we can use our sense of touch to detect collisions. Say someone's tapping us on the back, we can tell exactly when that happens. For computers, it's a bit more difficult. So to detect if things are colliding with each other, it's got to run these math simulations for every frame that happens. So if we were to press Shift A and add a plane here, S to scale, and then press add passive to give passive rigid body physics to this plane, meaning that it's now part of the rigid body world simulation group, but also that it will be locked into space. And we select this cube, G to grab, middle mouse to constrain, and then we press play here. As you can see, collision happened between the cube and the plane. So if I press pause and go back, and down here in my timeline, if I tap on the right arrow key of my keyboard, we can see each frame of this animation, and thus each frame that has been calculated in this physics simulation. So for humans, it's real easy for us to tell when things are colliding, but the computer is pretty much blind and has to totally rely on math, and that math can be quite costly in terms of resources. So to help deal with that, there's different shapes we can use for the computer to run these numbers, as it were. So if I click on shape here, we'll see that the easiest type is box. With box collision, that means that the computer only has to run math tests for 6 different sides. If we were to change the collision shape to sphere, it would now be running quite a bit more tests. If we were to say press play, well, the cube falls straight to the ground because nothing's moving it. But if we press pause and go back here and say, let's press D to duplicate a few more on here so they'll land on top of each other, and press play again. Well, they still fall right on top of each other, but say if I were to pick one up and then move them, you can see that these cubes are now moving like spheres because the collision detection is being used of a sphere and not the actual mesh of the cube. So if I press pause and go back here, and I'll press Control Z a few times to undo the movement I did while the animation was playing. That's what was going on there. And so we have capsule, which is useful for something like, say, this monkey shape here. So if I press add active for the monkey and under shape, change this to capsule here. The capsule is similar to the sphere shape, and we could switch this to cylinder, which will obviously give us a cylinder shape. So if we press play there, it's going to just move like a cylinder. However, if I were to press 1 to go into front view, R to rotate, Control to constrain to get this to constrain exactly, and maybe go ahead and scale this plane out here, press play, we'll see this is now moving like the cylinder collision shape, which is controlling it. And of course, we're only going to see these lines here in the 3D view. If we look down in our camera here, or when we go to render, we won't see those lines. They're just there to let us know what's going on. So press pause and go back there. So we also have cone shape there, which I think you get the basic idea with these collision shapes. And then we have convex hull. Will create collision bounds across almost the entire object except for very specific situations, which I'll explain in a second. So if we press play, we see that the collision is now much more natural, much more in line with the actual shape of the object. But if I were to say double right click here and add a torus shape here, and let's say press add active here, and under shape use the convex hull, you'll notice something different happening if I say position this where these cubes are here. If we bring this down, then press play here, notice that the cubes, when they fall, and of course they're rolling because they have a sphere collision on, notice that they're not going through this actual torus shape here. And that's because the convex hull is really useful for collision settings where something doesn't have holes in it. So same thing with this Suzanne head here, which we have convex hull collision on. If I were to say, select some of these faces, press E to extrude this inwardly like this, and then say press back here, maybe rotate this around, maybe bring one of these cubes over here, press 5 to go into top view. I'm going to go ahead and turn on high def shading so it's easier to view here. Maybe scale this down, G to grab, and then duplicate this a few times. Notice that those aren't going to land inside that crater in the head because the convex hull collision shape basically just conforms to the outer shape of the object, but it doesn't bother with like inner surfaces. So to get the best collision checking, what we do is use mesh. Now it's the best collision checking, but it's also the most expensive in terms of resources that have to be used. So, use it with a bit of discretion. For instance, with this torus shape, if we change the shape to mesh, there's now going to be collision checking for every single face that exists on this object, which is, as you can imagine, a lot more math to run than, say, only checking for a 6-sided box here. So if we press play, notice that everything now falls into this torus shape and moves as we would expect. Press pause here. You'll notice that for some of these collision types, we also get this option to the far right here, and it starts out by saying deform. This is the mesh source option. Basically what this is asking is, when doing these collision checks, should it just use the base mesh, or should it also check for the faces generated from modifiers that you add? So for instance, if I were to double right click here and add a cube here, and G to grab, middle mouse to constrain, bring it up. Say I were to change, well, first of all, add active physics to this cube here, and say I were to change this shape to mesh, and say rotate it a bit so it will fall over when it lands on the ground. And also my view is getting a bit messed up, so I'm going to hold Alt, tap middle mouse to zoom in on the selection, which corrects my view plane if it ever gets wonky. So now if we go back and press play here and we watch this cube fall, it's going to land on that edge there but then tip over. So if I were to tap W, which adds a subsurface modifier, and press W a few more times, which increases the subdivision level there. So a basic cube with a high level of subdivisions of a subsurface modifier will almost make the cube look spherical, but if we were to say press tab to go into edit mode, select one of these faces, press E to extrude, E to extrude again, S to scale, do something like this or something. If we press play now, we'll notice this fall over like that, but if I were to press pause, go back, and rotate this some more, press play again, really, the only collisions that are being taken into account are this object's core mesh. So if I come over here and press this eye icon to hide the visibility of this subdivision surface modifier, here's what this core mesh object looks like. And also with this set to deform or just base, the only collision checking that's going to be done is this actual shape here. If we want the absolute best collision checking, if we're using something like a subsurface modifier, we would switch this to final, and then the physics simulation will actually be taking into account every face that exists with the added effects of this modifier. So if we press Z to go into wireframe, every one of these faces are now going to be run in the physics simulation, which, as you can guess, is going to be a lot more expensive in terms of resources, but deliver us much better results. So if I press Z to go back into solid viewport shading, press back, and we could press origin to object, which will reset its center of gravity in addition to moving the origin point, which that's what that is. Notice it's going to behave more how we would expect it to. But in any case, the collision checking is actually happening for every single face that exists, even with the added effects of the subdivision surface modifier. So just keep that